quadratic equations. Remember we talked about solving them by factoring, square root method, completing the square, quadratic formula. So we talked about all these different things. Today we're looking at inequalities, which are very similar, except instead of an equal to, it has a less than or a greater than. And we're going to start off the same way. So we have to factor this. All right, we're going to find out what makes it equal 0. So if I factor this, what multiplies to negative 12 and adds to negative 1? All right. Now, this is where it changes a little bit. You cannot just say both of those things are less than 0. What we need to do, though, is figure out what makes it equal 0. So what would make this equal 0? Positive 4 and... Okay. So what that means is if we drew a graph, this thing is going to hit the x-axis at positive 4 and negative 3. Now, am I making a nice elaborate graph? No, I'm just doing the most basic of graphs. It hits at negative 3 and positive 4. Those are the x-intercepts of that graph, where it would touch the x-axis. Does this one open up or down? Up. We know that about parabolas, if it's a positive x squared. So our graph would look something like that, right? Something like that, maybe a little nicer. Okay, if your graph is above the x-axis, that means it's positive. Where it's below the x-axis, that section's negative. And this section is, again, positive. We wanted less than 0. Less than 0, is that positive or negative? Negative. I'm asking, when is this graph less than 0? That just means, when is it below the x-axis? And so it's from everything between negative 3 and 4. If it's an inequality, you're always giving me an interval. It doesn't have an equal to, so would it be parentheses or brackets? Starting at negative 3 and ending at positive 4. So that's my answer. Any number between those would make that inequality true. So we're figuring out when it's 0, and then we're thinking about the graph to answer the final bit. All right, let's try another one. Why don't you guys give this one a shot before we talk about it together? Okay, did you guys get that x is equal to 5 and negative 3? So if we think about the most basic of graphs, just a number line, negative 3 would come first, and 5, those are the places where it hits the x-axis. Does this parabola open up or down? Okay, I wanted less than 0, less than is the negatives, equal to means, so it's bracket negative 3 comma 5, also with a bracket. Those okay? Let's try a couple more. What would I have to do on this one? Yeah, x squared plus 5x minus 24. So multiply to negative 24 and add to positive 5. Be positive 8 and negative 3. We divide our 2 back. We get x plus 4 and 2x minus 3. So if you set that equal to 0, what do we get? Think about the graphs. Negative 4 and 3 over 2 are the two places it hits the x-axis. It was a positive 2x squared, so it's opening up. What answers did I want this time? Positives, greater than 0. So that's these two sections. So we have to write the interval for both. So this one's coming from negative infinity until negative 4. It had an equal to, so the negative 4 gets a bracket. Union, equal to, so bracket, 3 halves to infinity. Good. Why don't you guys try D then? You have to slip and slide. So that factors into x minus 12, x plus 1. Divide your 3 back, so we get x minus 4, 3x plus 1. So the two numbers that make it equal 0 are 4 and negative 1/3. You get that? All right, so if we think about the number line, those are the places where it's equal to 0. Our parabola is opening up. Most of the time that's going to be the case because anytime we try to factor, even if it were a negative x squared, we always rewrite it so it's a positive, right? So by the time we get to this point, we should have an upward facing parabola. We want it greater than 0, so that's positive. That means above the x-axis. So it's above the axis twice. Negative infinity to negative 1/3. It wasn't equal to, so that's a parenthesis, union 4 to infinity. So you might have caught on the less than, we were getting 1, the greater than, we're getting 2. It's kind of related to like our absolute value inequalities. Less than was an and, we got 1. Great or was an or, we got 2. So it's very similar there. That rule works as long as you rewrite it so it's a positive x squared before you make that determination. All right, I want to do just a couple other cases, a little more abnormal, and then I'm done for today. So let's take a look at this. All right, we do not like a negative x squared if we're going to try to factor. So my first recommendation is multiply everything by negative 1. When you multiply by a negative 1, what happens to your inequality? Okay, so it's now a less than problem. We try our slip and slide. What multiplies to positive 15 and adds to negative 1? Nothing? Yeah. So what do we do if you can't slip and slide? Quadratic formula. Let's try that. All right, so quadratic formula, opposite of b plus or minus the square root b squared minus 4ac all over 2a. So my b is negative 1, so the opposite of negative 1 would be 1, so minus the square root, negative 1 squared minus 4 times 3 times 5 over 2 times c. So in here, I get 1 minus 60, so that's a negative 59. What does that tell me? It has an I in it. Okay, if you're graphing and you're getting I's, does that equate to anything on my x-axis? No, I'm telling you this parabola never touches the x-axis. Okay, so that means my answer is either everything or nothing. We need to kind of figure out a little bit about what this graph looks like. We can go from either one. Let's just stick with this. Let's plug a number in here. If you put in 0, what do you get out? Get 0 minus 0 plus 5. So you're getting 0, 5. Okay? If I'm looking at this, I know it's an upward facing parabola. It never hits the x-axis. So all I really know, I mean, I'm just guessing on that graph, but it looks something like this. I wanted to know, when is that less than 0? No. Now, if I'd been finding when it was greater than 0, it would have been negative infinity to positive infinity, because that graph was always above. So if you get an imaginary number for your x-intercept, your answer is either going to be no solution or negative infinity to infinity. You just need to double check which one it is. Does that make sense? Let's look at this one. What would you do first? Subtract our x squared. All right, and then we don't like a negative x squared, so how could we fix it? And when you do that, it flips your inequalities. You get x squared minus 2x minus 4 greater than or equal to 0. All right, what multiplies to negative 4 and adds to negative 2? But that doesn't add up. So what do we do? All right, opposite of b would be 2. Plus or minus the square root of b squared minus 4ac over 2a. Okay, so I get 4 plus 16, so that's 20. I can break down 20 into 2 radical 5. Divide by 2 and I get 1 plus or minus the square root of 5. Okay, is that pretty? No. Is it a real number though? Yeah. If you think about your graph, it's hitting at 1 minus the square root of 5 and 1 plus the square root of 5. So you don't have to have nice numbers. We multiplied so it was opening up. Once I did that, did I want the positives or the negatives? Positives. So greater than 0 is here and here. So what would my answer be? Perfect. And this one had an equal to, so I should have brackets on my 1 minus radical 5 and 1 plus radical 5. All right, so don't be alarmed if you have radicals. All right. Questions here? Do we need more of these? There is a Math Excel assignment open.